So next we'll solve another question. This is also asked by one of my students. So the question is, a ball has 50 centimeter diameter. So that diameter of this ball, you can see in the figure, is 50 centimeter and its weight is 2 kilonewton. So it's a spherical or circular, the front view is circular object, so its weight will act at its center of gravity, that is at its middle, so at the center, and it is given that it is rests against a rigid block. So this is a rigid block, it is supported by this rigid block, it is rests against a rigid block. So it is given that the thickness of this rigid block is 20 centimeter. So it is asking, find the least pull applied through the center of the ball. So here the pull force P is applied at the center of this ball. So we have to find out that the least pull that is required to turn the ball over the corner of this block. So what is this pull force? We have to find out this. So we have to assume that the surface is smooth, so there is no frictional force acting on this block. So suppose this point is B and this point is A. Here there is one reactive force acting at this contact point. You can see this is the reaction force that is acting at this contact point, and here the weight is acting vertically downward, and there is a pull force acting. So to find out this, we have to balance the net moment. So we have to find out this force. To find out this force, we can calculate the moment from here. So if we'll, here three forces are acting, but if we'll calculate the moment here, the reaction force is passing, the line of action of this force is passing through this point. So the moment created by this force is 0, because the perpendicular distance between the point and the force is 0. And what is the perpendicular distance between is 0, and what is the perpendicular distance between this force and the point B? So it is the radius of this block. So what is the radius of this block? Its diameter is 15 centimeter. The radius of the ball is 50 by 2, because diameter is 50, so radius is 25 centimeter. So here to here the distance is 25 centimeter, and we have to find out the perpendicular distance between the weight and this point B to calculate the moment. So for this we have to find out the distance AB. So here to here total distance is the radius of this ball. So radius is, total distance is 25, and here to here it is 20. So here to here it is 20 and total is 25. Here to here it is, this length is, the radius is 25, and here to here the thickness of the block is 20. So here to here it is 25 minus 20, that is 5 centimeter. So here to here, to find out the distance, we will use Pythagoras theorem. So how we can find out this? Suppose O is the center of this ball. So AB is square root of OB square minus AO square. So what is OB? That is 25 square minus 25 square minus 5 square. So 25 square is 625, 5 square is 25. So square root of 625 minus 25, that is square root of 600. That will be the distance AB. So we have to find out the moment about B. So taking moment at B. So the P force is acting at this point like this. So it will rotate like this. About B it will rotate like this. So it will produce a clockwise moment. So sign of the clockwise moment, we usually take this as positive. So P into 25, and what will be the moment created by this weight about this point B? So how it will try to rotate the body? it is acting like this, so about B it will rotate like this. So anti-clockwise moment, so clockwise moment will be balanced by anti-clockwise moment. So P into 25 equal to weight is producing anti-clockwise moment and the magnitude of weight is 2 kilonewton, that is 2000 Newton. 2000 into the perpendicular distance AB, that is root over of 600. So we can find out the least pull required to turn the ball over the corner of this block. So you can solve this equation and you can find out the value of P.